Greetings, I'm Rob Sabourin, and I've been teaching software testing to programmers as part of product development for over 20 years. I'm an independent consultant. I'm an adjunct professor of software engineering at McGill University in Montreal, Canada, and I created one of the world's first mandatory undergraduate software validation courses at McGill University starting about the late 1990s.
I am Wodzislawski and have been teaching software testing to developers for over 15 years. I am also an international consultant in software quality and testing at the Centro de Ensayos de Software in Uruguay, and I am a professor of software engineering and testing at the Universidad de la República in Montevideo, Uruguay. As testing providers, service providers, we detected that applications of poor quality distracted us from finding the most subtle and severe bugs. And second, we think there is a lack of knowledge about the wide range of testing activities. That's why at CES we decided to teach testing to developers as a contribution to software quality.
Why? What's the motivation? Why train programmers about software testing? And we've looked at it and we've realized there's a lot of different reasons. And some of them I feel are strong, and some of them are weak. And it's important to know at the beginning, why are people doing this? I've looked at my case. Students have different reasons. The best sometimes are strong motivations like business reasons. I want to get more profit. I want to make more money. So we basically say maybe by teaching programmers more about testing, they'll be able to lower the cost of development, focus on developing new software instead of fixing old bugs, finding problems and doing less rework. It's also possible that sometimes the motivation is personal, that the programmer wants to improve their professionalism, to be better professional and enhance their professional status. For example, making and keeping commitments. If you teach developers more about testing, maybe they can make and keep commitments better. Maybe they can estimate better. Maybe they can build the right code and build the right code well. And with a bit of time, they'll build a reputation for someone who builds quality code. I want you on my team. You build quality code. You know about elements of software testing before you even write the code.
Yes, that's what I was trying to explain why at CES we prepare these courses for teaching testing for developers. And last but not least, I think we promote professional responsibility and ethics, both ours, Rob and mine, and our students also. There are many, for example, there are many courses on coaching or agile methodology, but very few of them cover the importance of software testing to succeed. Shift left testing, that is move testing as early as possible, requires strong testing skills, and we can even shifting left as far as including clients and users, but we need skills.
So if I can complement that, yeah. I think that process motivation is important, and it's the work we do as developers is part of software engineering to make products. So it's one small part. There's a business process around us. And certainly some organizations contact me to develop training or to deliver training to developers to help them with these process in motivations. For example, as you said, a shift left. This is very popular in Canada and the United States, where I spend a lot of time working. You go in there and the management doesn't really know what it means. They sometimes say, okay, if we're going to shift left, we're going to move testing earlier. That's good. Therefore, we don't need testers later. So they go and they take all the testers and they give them new jobs. And then they expect someone like me to come in and magically, put the magic in there and say, okay, now the programmers can do good test design. Of course, it's a risk, right? It's a process motivation. The motivation is good, but sometimes the just process without sort of rational organization is risky. I've seen programmers being asked by managers to learn how to do test-driven approaches of development, or acceptance test-driven approaches of development, or behavior-driven process. These are process models. They're beautiful models, but each one of them is taking a view of the activity that has to be done without necessarily emphasizing the skill needed to do the activity. So we have, I think, a lot of interesting things. And a lot of today, the dominant one, I think, as you were saying, dominant is the agile transition, where people are going in there and they're saying, quality is now the whole team's responsibility. So therefore, everybody has to know how to find quality problems and fix them early. And this becomes the motivation to teach everybody in the team better testing, which is, I think, again, a reasonably good process motivation, but sometimes insensitive to the need to develop the skills. We have a lot of different form of developing and delivering training. It's not just one form. It's not just download a video and watch it on YouTube. There's a lot. And just to give you a quick nutshell in the few seconds we have, big bang for me. I'm asked to go in and you put all of the programmers in a big room and then Rob make a speech, show examples, and that's it. And they walk away. And for me, it's like, I guarantee there's a lot of Teflon because of the approach, because there's no individual feedback. There's no way for me to see what people are learning as they go. And at the same time, their takeaway is like a template, not knowledge. And I think that's naive a bit, but people do that. And I have to eat. I've delivered that. I'm guilty. There's training we do very often that's public. So we offer a course and it's public. So it's filled with people from different organizations. This is a nice thing for people to meet their peers from other companies, but this is, of course, risky in many ways because people come from totally different environments. How do you sort of normalize that? We do also better to normalize it. Sometimes we take that course and we drop it into a company, and this would be parachuting a course into an on-site context. So I go to your company and deliver the training. That's different from public because there everybody's usually using the same methods and techniques, but it's also a canned course. The learning objectives are what I generalize, not what's specific to the skills of the people. Drop in an Agile Methods course into the team and put in the coaching as well. So you stay there. So you go, you work with the team, you deliver the training with the team as they're doing the development, and then you provide them feedback afterwards. This is the Agile coaching sort of integrated into the team approach. Did you have any comments on those?
No, I would like to speak about our testing in Agile methodologies because our course on testing in Agile methodologies is an agnostic course. That is, it is completely independent of Agile methodology flavors and software tools. I like it because it is a thread connecting the history of software engineering with current demand. That's why I like very much it, and I prepare it with love and dedication.
Agnostic.
Yes.
No, that's important. That's an important fact.
Because we have this course for many years. We have dictated this course for many years, and we try to permeate the development process activities with testing insights, strategies, and tools. It contains not only techniques, but testing culture. This includes quality objectives, risk analysis, testability, post-analysis of bugs, unit integration and regression testing, manual and automated. So it's very complete. I
have a couple of comments on the academic courses. So I've, of course, worked a lot in both the academic world and the professional world. And Monica has worked a lot in both the academic world and the professional world, which is why we're here. We are, I think, very unique in our experience in that we straddle both worlds. And so we see what the business needs are and also what the academic needs are. My dream is everybody who graduates with a degree in computer science or engineering has a strong knowledge of testing and how software testing fits into the process of getting things done with software. Myself personally, I've been involved in many different contexts. I've built courses on software validation based on really deep, a semester-long study of a case study. So a big case study, and we just dive in deep. Then we basically also have courses in software engineering, the practice of software engineering, where again, we dive in deep to look at where testing fits into the practice. And we don't just assume there's one method. In fact, we interview people and we look at many different methods. Last semester, we had, if I'm not mistaken, over 450 different methods that we studied as a group at my class at McGill. It's not just one way, But the beauty of it is you see the variety. And of course, you have a semester. It's not just one day. It's a whole semester to learn.
Yes.
And
We succeeded in including explicit testing activities in several undergraduate programming courses. Students were encouraged to bring their own test cases, and the slogan was "Post your test case, build quality collectively." I think it was interesting.
Cool.
And we have another an elective course, software testing workshop, and the vast majority of students are already working as programmers and choose these workshops to complement their testing knowledge. This was a motivation that Robert talked about. The workshop topics include functional testing, testing automation, and performance testing, with a theoretical and practical approach. It is rewarding to mention that several workshop students become so interested in software testing that they have picked this subject to their degree thesis. Last but not least, with these formats of courses, we have a graduate course about performance testing. The main objective of this course workshop are that students learn the need to run performance testing, first of all, incorporate the related concepts and methodologies, delve into performance testing strategies and techniques, apply different tools, and learn how to manage performance testing projects.
And I think you're tackling it at the right level too.
It's a full semester, yes.
A full semester. You know that there's so many people who are looking at testing programs, and they even completely forget to put emphasis on non-functional stuff.
Yes, I know.
Today, with AWS, Azure technologies, the world we're in, people think magically you get scale, and it doesn't happen for magically.
Yes.
You have to build it in. So teaching that performance testing at the graduate level, I think it's a very good idea. If I have a group of people with a mixed SDLC, that's the software lifecycle model, and technology stacks, I find that the students get really, really distracted by the configurations and technical nuance of the setup. So one thing I find that does not stick, it's like Teflon, is if I have to spend all of my time worrying about the difference of life cycle and the difference of technology stack. So this one is, to me, 20 years of it's just not the point, right? The skills are the point. So I find it's distracting, but you have to do it, because if everybody uses a different technology stack, well, you have to talk about how they fit into the IDE, how they fit into the tools, and the tools, especially for things like mocking, dramatically different for different technology stack. Then there's something I love to do in teaching is paper and pencil problem-solving exercises. And I think anybody who's been teaching for years will love to give people problems to create a model and solve the problem. Well, a lot of the programmers I've worked with have limited patience for paper and pencil exercises. They want to program. They want to code.
Yeah.
Also, programmers, very often I see, they may understand a simple example, but if the example is too trivial, they actually block it. I see they don't really see, how does this trivial example apply to my complicated code? And I saw this so much in a major American insurance company. I was amazed. So I basically had to go in and mine the code, their code, for real examples of every single concept, and then show them their own code. It was a lot of preparatory work, and of course, when you're doing that, you're looking at code that someone else wrote for other purposes. So it's like becoming like Sherlock Holmes to figure it out. And let's see. So they want complexity at the level of their day-by-day work. Also, when you have exercises, and I love to do exercises in classes, I find that some programmers turn this into a competition, and it's like they want to be fast. And so what I see is, some developers are racing to finish the exercises, and other ones are maybe struggling with them. And I have all this painful waiting times. When the exercise is done, to synchronize the class, sometimes someone has to wait 15 minutes when they did the exercise in 2 or 3 minutes. I thought the exercise would take 10 minutes. it takes 2 or 3 minutes. They get competitive. So I've got to rethink how I give exercises in that context.
Rob, we need continuous exercising, continuous testing, continuous integration.
There you go.
Continuous. Exercising also.
We see people who are very tool-centric and tool-specific. These are usually, for me, vendor training courses. I've been hired to take these courses to audit them for companies who are being asked to spend a lot of money on training. And I have to say that the vendor-specific, tool-specific training is just what it said. You become someone who becomes a toolsmith, right? How do I use this tool? Not how do I solve my problem, but how do I use the tool? I don't want to criticize that. I think it's important to have that type of training, but don't pretend you're teaching testing skills to programmers with those type of courses. Coverage models, I find that sometimes people learn one coverage model, like code coverage. I just last week spent 3 hours in a workshop on coverage models by one of the world's biggest software tool vendors. And it was naive. It was naive. There's over 100 different coverage models, and you got to choose the model that helps you solve the right problem, and not just find one model and say everything's got to resolve around code coverage or path coverage or requirement coverage or something like that. So I think there's risks on these things. Nothing wrong. Coverage models are important, but pick the right one. Pick the right one, and make sure you do it on purpose. Let's see, what else do we have? Templates. I'm afraid that many training providers, especially methodology-centric ones, show you templates. And I love templates, okay, for some activities in the world, they're good, but for software engineering, I think we need more case studies and less templates. The templates—
we need to think, you know.
It tries to take away the thinking, exactly. And so templates, for me, I'm afraid, I don't want my programmers to become template zombies. And most of them don't like templates, except for certain types of like patterns, which they sort of want to follow. And that's another subject, the patterns. Code-centric focus. So not all testing is designed by writing code or using libraries. It's a cognitive process. Maybe when you run it, you'll be writing some code or doing some coding, but it's not the doing the coding part that I want to teach you so much as the thinking part.
Yes.
And last one is regression automation focus, which to me is dominant today in the DevOps world. You see DevOps, tools, regression. And yeah, okay, you can build a lot of confidence with having thousands and thousands of regression tests, but man, that's only a small part of testing in software engineering. And yet you see a huge amount, I don't know how many percent. Last year, I went to America's biggest software testing conference in Anaheim, California, and I went to the vendors, and it looked like over half of the vendors were basically trivializing testing to developers as being set up an automated dashboard so that during your DevOps cycle, you can see pass-fail tests on regression. And that's okay, but for me, it's not the dominant problem of testing. It's one problem, and it's not the only thing developers should be concerned about. But today, of course, we have a lot of risk that area, and for me, this is a Teflon.
We need testing in all levels, not only at regression testing. So
absolutely, and different types of testing at all levels.
Yes,
too.
Different types. Yes.
Yeah.
And
so, do you want to add anything to any of these Teflons?
No. Let's go to the Velcro.
Aha!
Instead, I like Velcro.
Velcro is more important than Teflon, maybe.
Yes.
Maybe. Okay. Here we are, Velcro. So I have a few points. Brainstorming test ideas. I find that sticks. Whatever method, whatever SDLC, get the programmers or get the team together, and before they start implementing a feature, brainstorm the test ideas. Now, not all of them will necessarily be done by the programmer, but you have a deliberate notion of what's required before you start. Programming exercises, many, as you said, all exercises all the time, and have them build complexity. So if you finish the first one, make it a little more complicated, do the second one, then the third one, the fourth one. So even if one delegate doesn't get through all levels, you can still keep them busy and challenged while the class is going on. And make the exercises related to the problem space that the engineers are working in. Risk models. This is for me absolutely fundamental.
This is basic.
And yeah, it's something for me. I want to make things real. I want to make things real. We're doing this work not for fun. Well, maybe it's fun, but we're doing it because we have some sort of a reason. And so we can't test everything. I think risk models help people focus their testing, looking at things like the business risk and likelihood of failure, and other models, benefits, consequences. There's lots of different models, but it's important for me for people to do things deliberately. Do you have a comment on that? Risk models?
Guide the testing and the development too, also.
Exactly. Guide the programming, not just the testing.
Yes, not only the testing.
I think another thing that sticks is showing the application of fundamental techniques to relevant problems that matter. Don't just trivialize, here's a fundamental technique, but show how that fundamental technique can help solve important problems that matter. Yep.
This is the antonym of the trivial examples in Velcro, in Teflon.
Yeah, so you take the same problem and you see.
Yes, the same problems you see.
The opposites.
Both views. Yes.
And the last one that I love to really say this sticks the best is to look at real bugs that escaped. Look at real bugs, if you can, from your real projects that escaped, and try to learn, how did the bug get there? How did we find it? Can we change our process to catch it earlier or to avoid injecting it in the first place? And this is the Deming loop, right? Plan, do, check, act. Look at the results of the work. Look at what caused the bug to get there, and fix the process, or fix the method, or fix the technique, or fix the tool, whatever the root cause is.
We work both with the errors students make frequently and the tests that were not written to detect those bugs. At the end, the students prepare or are able to prepare an improvement plan for each person and organization.
There you go.
To avoid these bugs in production.
Yep, and avoid them as early as you can.
Preventing them.
Very good. Bug prevention, you hear about that, the terminology. Probably more important than just the notion of shifting left is to prevent problems. Build quality in, as they suggest. Let me shift to the next slide here. This is Velcro. Velcro, things that stick. Okay. Quality goals. I think this is some beautiful. And not just your quality goals, but what's the stakeholders' quality goals, right?
Yes, that we encourage developers to discuss and set quality goals for the software product they will build, and to pursue the most appropriate standards or guides in the context. For example, if the goal is security, they have to use OWASP as a guide, for example, to learn vulnerabilities and so on.
Yeah.
And this awareness of quality objectives helps risk identification also, and mitigation, of course.
I think there's a very important room for this in training. A lot of people learn how to program it well. They develop good programming skills, but they never ever realized how important some quality goals are. And once they start building it into their thinking, they'll change probably the method of programming.
Yes.
Conceptual models, I think problem-solving approach, create a model, check the model against the results, adapt, learn, and go. I think this is a way of thinking. It's a way of life. I learned this as a problem-solving approach by studying Polya, the work, How to Solve Problems, written in the 1940s. It's like a lot of people intuitively know this, but they don't sort of turn it into something that's part of their day-by-day work.
Also, developers realize that this prevents them from making many of the most common mistakes.
That's it. The models encapsulate.
Yes, the model for test design
Mhm.
can be used to development.
Which leads to the subject of patterns and anti-patterns. I'm not the world expert on the subject, but I'm afraid of it because patterns that solve one problem don't necessarily solve another problem. I spent a lot of time a couple of
Yes,
years back
you
looking at
know,
the subject.
we use these patterns and anti-patterns um, to developers for teach good practices, especially for testing automation
Mhm,
and for performance problems recognition. If
exactly.
you program like this, you will have this problem
That's
because
that's that's
it's
that's
an
true.
anti-pattern.
I think that I want to point people to the publication by Dorothy Graham in her book, A Journey Through Test Automation Patterns, One Team's Adventure
Yes,
with Test Automation Patterns. There's a wiki
yes,
and a book on the subject, and it's truly revealing. But as you said, these are automation patterns, and
yes.
that seems clean. What
And
I'm afraid of,
performance patterns and anti-patterns when you are
yeah,
developing.
today in programming, there's risks with patterns because some of the goals of non-functional quality goals changed. For example, a lot of people who learned Java coding strategies for searching and sorting learned patterns of programming that optimized memory and optimized CPU. But
Yes,
today, there's a serious problem with code that if it consumes too much power, it makes it makes the software weak. For example, your cell phone battery dies. Now,
yes.
the pattern to optimize your code to minimize battery use is not necessarily the same one that minimizes
No, of
memory
course.
you. So you've got to be sensitive to both quality goals and the patterns, and then choose them
Yes.
related. So there's a correlation between the two, and I think that's important. Maybe that's why I keep talking about case studies, because case studies, detailed case studies, can help us learn the relationship between quality goals and patterns and anti-patterns. So I think
And you know, yes, it says taking care of confidentiality, of course.
of course,
We have a wealth of many examples from real customers. So we use to teach.
yeah. And I'm right now preparing my semester for the fall semester at McGill, and I'm going to be doing part of my course is to teach people how to create tests, how to create case studies. So it's not just study a case study, but it's to create one. Sort of a case study
Yes,
can become a deliverable of the software engineering process. It's pretty cool.
that we do also.
And of course, think that you have to be passionate about software engineering to realize looking at problems, looking at real problems that happen to real people historically is one of
Yes,
the best ways to learn about testing. And people have put together beautiful collections of what we call taxonomies of failures. There's, of course, Ken Kaner's common software errors. There's Boris Beiser's collection of what can go wrong with software from the point of view of programming mistakes. There's
yes,
several from Florida Institute of Technology at their graduate level where they studied common defects found in transactional e-commerce or common defects found in mobile applications, etc. It goes on and on. There's many of these collections.
yes,
And by studying the collections, you start realizing about risk and risk models, but also about quality concerns based on what really happened on real systems. And I think it's just, for me, one of the best things to sort of include in the course and not just talk about it, but show it. Salt and pepper, take it like
yes.
seasoning, salt and pepper. Don't leave it alone. Put it in every example, every exercise, every part of the
Yeah.
course. And that will help inspire. I think reality helps to inspire things. It really helps it stick.
So, as a final remark, I would like to say that we enjoyed writing this article and sharing our experiences on this somewhat underrated topic, testing in development. And we feel that hard skills are essential for building and testing quality software. Also, that the problems are very similar, even though we live and work in quite different contexts.
We do, and it's been fun putting this together. This is a paper and a presentation that literally took over 15 years to put together. We thank the organization at PNSQC for supporting this little project of ours. Thank you very much.
Thank you for being here with us.